Welcome, ladies and gents. We're going to talk about complex fractions in this video. So when you are looking at a complex fraction, it's a big fraction with lots of little fractions inside of it. That's what makes it a complex fraction. And to simplify these, you need to begin by finding a least common denominator for all four of these fractions. So just looking at these, I have 8, 2x, 12x, and 3x squared. The least common denominator, at least for the integer part of it, would have to be 24. And then for the variables, you want to take the largest, so x squared. What you do with that is you actually multiply it all the way through your fraction, and I will show you what that looks like. So when we multiply that least common denominator all the way through, this is kind of what we're doing here. We're multiplying by 1 in a very clever way. So you know that when we multiply by 1, it doesn't change anything. So if you have 24x squared divided by itself, that is 1. So technically that's okay to do in this case. Now when I go to multiply it through, I want you to remember how to multiply fractions. So let's say that I had 3 times a quarter. All right, we know that it would become 3/4. So really what's going on is you are multiplying the 3 by the numerator, and that happens because technically it's 3 over 1. Just keep that in mind when we multiply these. The 24x squared, here and here, they're both going to be multiplied only to the numerators. So let's go ahead and do that. If you want to take just a second and try it yourself, pause the video, otherwise I'm going to move right ahead. Okay, notice that I have taken my 24x squared and I've multiplied it to this numerator and this one, so I now have 24x squared over 8 and 24x squared over 2x. I've done the same in the bottom. Some people don't like to show this step. If you're new to doing complex fractions, I would show this step just so that you kind of keep yourself on the right track, you don't mess anything up. Some people like to simplify it right away and they like to skip to this next step that we're going to do. So you want to reduce each of these fractions as much as you can. 24x squared divided by 8 would be 3x squared. Over here, 24x squared divided by 2x would make 12x. Right here I would have 2x, and right here I would get minus 8. Now you might think that you're done, but just looking at this I can tell I have a quadratic and then I have some stuff with a GCF. So I definitely want to try and factor anything that I can. In the top it looks like I can pull out a GCF of 3x. When I do that I'm going to be left with factors of x and 4. In the bottom, 2x minus 8, I can pull out a GCF of 2. I'm also going to be left with x minus 4, which is really nice because then they can cancel. So my final answer for this problem is simply going to be 3x divided by 2. Alright, now on to one that is a little bit more complicated, and I forgot to mention before, I was taking these problems from your homework, so that's why I numbered them. Okay, so when you take a look at this problem, I hope that something jumps out at you. This is definitely factorable. You can find a GCF that would go into those. And also looking at this quadratic, that should be factorable. So those should be the very first things that you do. Pause the video, factor them, and when you play it again, I'm going to have it all factored for you. Okay, so I'm not going to dive too deep into how to factor. If you forget how to factor, then you can check out one of my other videos. Otherwise, I pulled out a GCF here of 5, got x plus 2, and I factored this quadratic into x minus 4 and x minus 10. Now that's really helpful because if you look at my other denominators, that means that they share something in common. It's going to make it a lot easier to find my LCD. Right, if I have x minus 4 here, x minus 10 here, and both of them here, then my LCD should be x minus 4 and x minus 10. So again, just like we did in the last problem, you want to multiply both the numerators, I'm talking about the large fraction here, so both the numerator and the denominator by x minus 4 times x minus 10. Okay. So when I go to multiply these through, recall, these should be multiplied just in the numerators of these fractions. But also notice when I do that, if I have like an x minus 4 in the top of this fraction, it should cancel with that x minus 4, which is in the bottom of that tiny fraction. So that's going to leave me with x times x minus 10. All right, over here, when I go to multiply this whole thing times the 4, notice that it should cancel the x minus 10s and just leave you with 4 times x minus 4. In the bottom, if I were to multiply this numerator by x minus 4 times x minus 10, these would cancel with the whole denominator, and I would just be left with 5 times x plus 2. All that you have to do here now is simplify. So in the top I would have x squared minus 10x plus 4x minus 16. In the bottom, 5x plus 10. My hope is that something cancels, but if it doesn't, that's okay too. All right, x squared, this would become minus 6x minus 16 all over 5x plus 10. And you should be seeing now that this is probably going to factor, and it might cancel with what this was. So I'm actually going to put this back. I'm going to put back the 5 times x plus 2. All right, 5 times x plus 2. And in the numerator, I'm looking for something that multiplies to negative 16 but adds to negative 6. That should be x minus 8 times x plus 2. And voila, they do cancel. So you just get x minus 8 all over 5.